the introduction or programming fundamentals class. I sent out that video, and hopefully everyone saw the video that just gave the basics about the course. I'm just trying to see who all is here. For whatever reason, my participants went away. Oh, well, I have to figure that out later. But basically, I want to make sure that everyone has downloaded code blocks, okay, because that's the IDE that we're going to use in order for you to compile your programs and run your programs. You're all onto Teams, so that leads me to believe that you know how to get into Teams now, so that's good. Once a week, we're going to have this class, and in order to get your lab checked off, you're going to have to go onto Teams to the ECET tutoring team, and that's where you're going to go and get your labs checked off. And you just need to make sure that you add your .c file and your flowchart to each one of your labs, okay? And you're going to have to show that to the lab tutors anyway. Also, I wanted you to know that lab tutors are going to ask you questions when you, well, I guess you have tutorial labs. So the tutorial lab, just in case you're unclear about what that is, that's basically a way to clear up, to make me comfortable that you understand the concept. So you go to the lab tutor and they ask you a series of questions and you answer them just to verify that you do understand the material. And if you don't understand it, then they'll help you to understand it better. So it's just a resource for you to help you be successful in this class and to just really understand what it is that we're trying to do. Before we get started, here's a chance to ask any questions. Does anyone have any questions they want to ask me? If you do, you have to unmute so I can hear you.
I actually had a question.
Who is this? Say who you are, please. All I see is J.A.
James Allen.
James. Okay. Hey, James.
Hey, would you rather us, I guess that probably answered our question, but would you rather us speak on the mics or type in the chat?
I would rather for you to speak on the mic. Okay. Because as I'm talking along, I don't even see the chat anymore. It's hidden to me. So yeah, this is how I would like for you to do. I'd like for you to mute it if you're not saying anything, but if you have something to say, unmute and please speak up. Okay. Okay. And if I ask a question, anybody go for it. Unmute and speak up just so that we can try to make this online version engaging. All right. So it shouldn't just be me talking to you. It should be us having a conversation and you really engaging in your learning. So thanks for that question. Yes, Jane. Anybody else have a question? All right, so I know you noticed in your, if you looked at the syllabus, that class participation is a part of your grade. It's like 15% of your grade. So during this time when we're having lectures and stuff, I really want you to speak up, ask questions, answer questions. That's how you get your participation grade for the day, okay? So make sure you do that. If anyone has an issue with these lectures, please email me because I have alternatives that you can do instead. Say you have a job or you have another commitment because you expected this to be a purely online asynchronous class where you didn't have to show up for anything at a specific time. I understand that. So just let me know. The reason why we're having these lectures is that traditionally a lot of people have failed this class. And so I'm trying to give you every resource and help you as much as possible over the summer because it's extremely intense over the summer. You have to do in 8 weeks what would normally be done in 16 weeks. So that's the point of these online lectures. Oh yeah, and I was supposed to be recording this. All right, so just to let you know, I'm going to record this lecture for some people who can't make it. I can figure out how to do it. Let's see.
I think it's already recording.
Oh, is it? It does look like it's recording. Did it put up a little
Because-
statement saying you're being recorded?
Yeah, it says recording has started. This meeting is being recorded. By joining, you are giving consent for this meeting to be recorded.
Okay, cool. Thank you. Yes.
Yeah, I hope you didn't mind. I hit the record button.
No, thank you, Charlie, because I was trying to find it. No, that's good. That's good because for people who can't attend, if you can't attend, I still want you to have access to be able to see the lecture. So, nope, that's perfectly fine. Any other questions before we get started? None? Okay. All right, so then let's go ahead and get started. So let's just talk a little bit about the basics of computers, okay? So first of all, what is a computer? Anybody? Nobody knows what a computer is? You use computers every day.
It's a machine that can perform tasks if given instructions.
Yeah, you just got to give it the right set of instructions, right? So if you give it the right set of instructions, it will perform tasks. All right, so I'm writing down everybody's name as you participate just so that you can get your credit. All right, so let me get a pen. I think that's going to show up better. So you give it the instructions and then it performs the task. If you don't give it the instructions, it won't perform the task. And if you give it the wrong set of instructions, it won't perform the task that you are intending for it to perform, okay? So computers, so those tasks are put in what's called a program, right? So a program is a set of instructions to perform a task. That's what a program is. So we put those instructions in a program and then we run it and then the computer performs the task. So it might be kind of hard to see my graphics in black and white. The printer didn't work today, right? But this is a program right here and then you run it on a computer. Now, there are lots of system programs that we deal with every day with, and we don't know the ins and outs of them, but they know what they are. We know what they are. Somebody give me an example who hasn't participated today of some system programs that we use on our computers on a daily basis.
Would the system programs be the drivers that run in the background to run the main programs you're using?
Well, not the drivers, but they are programs that run in the background that help us to do certain things. So they're not the drivers. The drivers are these little specific programs that act as an interface between a program and a piece of hardware. That's what a driver is. But what are some of the system programs that you use when you turn your computer on or even your phone?
Can you hear me?
Yep.
So are you talking about something like Windows or like Android systems?
Yep. Who is this?
Susanna Bryan.
Susanna. Yep, that's exactly what I'm talking about. Okay. So Windows, Android, iOS. What do we make? What do we use to make like charts and tables? What kind of software do we use for that?
We use Excel.
Excel. What about if we just want to make a document?
Word.
Word, right? So these are some of the system programs. So basically, they're programs that manage the hardware and allow all the other software the computer uses. Okay, so basically, the computer needs to know when you can use Excel, when you can use Windows. The computer needs to know when you're typing into, when you're using the keyboard and when it's supposed to display something to the screen, right? So that's what these system programs do. They control the CPU and they let the input and output devices know when it's their turn to have to do something or to show something. Otherwise, you would just have all these different programs and nothing would happen with them. So they kind of organize all the other programs that you use. Actually, I'm sorry. Excel and Word, those are application programs. Scratch that. Those go underneath here. Sorry. They're not system programs. The system programs are just Windows, Android, iOS, you know, Mac, that type of stuff. Sorry about that. Okay.
Excuse me.
Yes.
This might be a dumb question. I just haven't had a chance to go through everything on Blackboard.
Uh-huh.
Are these lecture notes available on Blackboard?
They are. Mm-hmm.
Okay, thank you.
Yeah, so what you should probably do in the future is before the lecture, print out the lecture notes. And then you won't have to write everything down.
Okay.
Not a dumb question at all. I thought I put it in the intro, but maybe I didn't. So they determine what will display on the screen, how much time the CPU gives other programs, how much time. This is the problem with using a pen. All right, I'm gonna use a pencil. Y'all let me know if you can't, if it's too light and you can't see it. What I do with my pencil. How much time CPU will give other programs.
You need one of those erasable pens.
I know, even though this pencil is pretty dark. I had gotten some with darker lead, so I believe in pencils, right? We all make mistakes. That's just life. So I like to erase. I don't really like scratching out. It looks messy to me. But anyway, all right. So now application programs. So we got ahead of ourselves. So what are application programs? Anybody got a clue? We already said two of them.
Maybe like Gmail.
Right. But what do they perform? So basically Gmail is one. Gmail is one, but what do application programs do? How are they different than, say, like a system program? Anybody got a guess?
Do they perform specific tasks? Do you
That's
run on the computer?
That's exactly what they do. They perform specific tasks like Excel. Okay, that's for charting. I mean, you can do a lot with it other than charts, but it's a specific task. Word, those are that's like a text editor type of program. You have the program that you're going to use to compile. You have code blocks, right? That is used to compile and allow you to enter in C programs and then run them, right? So basically, those programs are what are called execution programs. So if you went and you looked in your program, so if you went into your folder and you looked underneath programs, you would find like the different applications. Say you went into CodeBlocks, you would see a program that was called something like CodeBlocks.exe. I'm sure you've seen plenty of exe files. Whenever you download any kind of software, you click on it and you run it. That is the specific application program. A lot of times you'll just see an icon on your screen and you just click on the icon and you're not looking at the name of the program, but that's what it is. Okay, it's an application program. Now, what you're going to be doing in this class, you're going to be making user programs, right? So those are other executable programs that you will create in order to do some specific tasks that I've asked you to do. Okay, so those are user programs. So there are three different types of programs: system programs, application programs, and user programs. And just remember, anytime you make a user program, you have to start out when you're typing it in and call it a .c, because that's the language that you're using. And then after you compile it, it creates a .exe file, which is an executable file. Okay. So we have a couple of different number systems that we deal with. The one that we use the most is the decimal system, right? Everybody learned that from the time they were in kindergarten, or probably even before, because you probably knew how to count some before you ever went to kindergarten. The reason why we use the decimal system is that humans understand it easily, okay? People think it might be because we have 10 fingers. Well, most people have 10 fingers and 10 toes, but I don't know why, but it's pretty easy for humans to understand that. How many digits are there in the decimal system?
2.
10.
Someone says 2, someone says 10. Which one is correct?
I said 10.
I said 10 too.
Hang on, can't you have
I
an
said-
infinite number of decimals?
No, how many digits?
Oh,
So the digits are different than the different places of the digit. So say, let's talk about the ones place. How many different digits can go in that place?
You can
10.
have 10. It's
10.
0 to 9.
Yeah,
Exactly. There are 10, right? Thus I said the 10 fingers and 10 toes. 0 to 9, right? If you're counting, once you get up to 9, what happens? Then you have to carry over, right, to the next place, which is the tens place. Then you have a number called 10, right? And then once you get to 99, what happens? You carry over again, and then you get 100, right? So those are your different places, but your digits are always 0 through 9. Those are the digits that we have in the decimal system, okay? Now, there are just some digits that someone came up with and said, this is going to be the digit. It could be hearts. It could be anything. It's just a symbol, right? But we have given the symbols 0 through 9 to represent digits in our decimal system. Unfortunately, yes.
Can you
Yes,
move
Charles.
up the paper just a bit?
Yep.
All right, thank you.
Unfortunately, computers don't understand the decimal system that humans understand. So that kind of sucks for us. So we had to come up with a different system, number system for computers. And we came up with the binary system, okay? Anybody know why we came up with the binary system other than the fact that computers didn't understand the decimal? Why the binary number system? Why not tertiary or something else? Why binary?
well, I know with binary, it's simple 0 and 1, which just equates to yes or no.
Exactly. Okay. So basically, if we take it to electrical engineering, we can represent, it's easy to represent electrically. Who said that? Who's JR?
Oh, sorry, this is Thomas Rodriguez.
Thomas. So what Thomas said is totally correct, because electrically, we can just say something is on or off, right? We can say, like Thomas said, if we consider logic, we could say something is true or something is false, which we represent as true being on and false being off, right? So that's why it's the perfect system for a computer, because a computer knows this is on or off, it's true or it's false. Now, how many digits are there in the binary number system?
There are 2 digits.
Two
0
digits?
and 1.
0 and 1. That's it. You only have 2 digits, on or off. 1 on, 1 true, 0 off, 0 false. Okay. Okay, let's go to page 2. Okay. So the number of binary bits that you have, it determines how many choices you can have. And the number of binary bits is the same as in the decimal system, saying how many places that we have, right? So if I write down 9, how many places is that in a decimal system?
It's one place.
That's one place, right? Because we only have one digit. And if I write down 99, that's 2 places. If I write down 999, that's 3 places, right? So think of places as a bit, okay? But when we're talking about the binary system, though, we like to assign bits based on how many choices that we need a certain situation to have. So if we have 1 bit, how many choices can that represent? Let me hear from somebody who has not answered a question. I want everybody to get some participation today.
It's just 1.
That Alexis?
Yes, ma'am.
Is it just 1? Because what did we just say about?
It's 2. It's
2.
either 1 or 0.
Right. So 1 bit can represent 2 choices, right? Because you can have either on or off, true or false. Okay. So if you had 2 bits, how many choices do you think you could have?
4.
Exactly. You could have 4 choices, right?
Yes.
So that's 2 times 2, right? That's 4. And it's the same thing. If you have 3 bits, you have 2 times 2 times 2, which is 8 choices, and 4 bits, 2 times 2 times 2 times 2, which is 16. Okay. So the number of bits you have determine how many different choices you can represent with those bits. So basically it's a formula, and the formula is if n equals the number of bits, then the number of possible choices is 2 to the n. Okay. Any questions? I feel like I'm talking pretty fast. Nope. All righty. So let's go on to CPU. So I know everyone has heard of the CPU before. What is it?
The central processing unit.
It's a central processing unit. So it's basically the brain of your computer. It executes instructions. That's exactly what it does. It's the brain that executes instructions. Okay. Now, when it comes to instructions and it comes to programs, there are several different types of languages. Just like in the human languages, we have a lot. I don't even know how many languages there are. There's a ton, right, of languages, because there's a lot of countries, and most countries speak, I wouldn't say most, but a lot of countries speak different languages, right? So there are several languages that you can use to talk to a computer, but no matter what language you use, it all breaks down to machine language. Okay. So say you wanted to add 2 numbers, 7 plus 5, right? You have to figure out how you can put this in machine language so that a computer understands it. And I already said that computers only understand zeros and ones, right? So how would we do that? Well, there's a language called machine language that has figured it out. And basically, what you would do if you wanted to add 7 plus 5, first of all, let's see how many of y'all remember your math facts from back in the day. What is 7 called? If you're looking at this mathematical expression, what is 7 called? Anybody know?
A whole number?
It is a whole number. It's an integer, but it's called something else when you're looking at an operation. It's been a while, so I'll tell y'all. It's called an operand, okay? And basically we would call it operand 1 because there are 2 operands there. So that would be operand 2, I mean 1, and then 5 would be operand 2. Can y'all see? Operand 2.
I never remembered calling it that.
I know. And then, your teacher might not have wanted to get into the technical math names because normally we would just say add 2 numbers and you just call it a number. But when you get, I'm trying to think when I remembered learning that. I don't know. I can't remember. I taught math too, so it's hard for me to, to know. But anybody know what the plus is called?
It's the operation.
Yep, it's the operator. Well, you can call it operation or operator. Operation, operator. Okay. So basically what's happening is that you're operating on 2 numbers, 2 operands, 7 and 5. You're adding them, right? So what will happen is that the machine language will take those 2 and it will give them, first it'll look like this, okay? So can you see why humans don't like it? It's a bunch of zeros and ones, right? It'll look like this. But what you'll have to do is that you'll have to break it up and you'll have to give a code that represents adding. You'd have to give a code that represents subtraction. Any kind of operator you'd want to do, you'd have to give a code for the operand 1 and you'd have to give a code for operand 2. So if we were looking at this in memory, it would look something like this. If we said add was 0, 1, 0, 0, I see 0, 1, 0, 0 right here. So that would be what we call an opcode. Okay, and then you would have to represent your operands. And so anything for y'all who haven't taken intro yet, if you have 3 bits and you have a bunch of zeros in front of them, it's just like in decimal. You just ignore them. If you see 111 in binary, that means 7. Okay. So this would be operand 1, your 7. And then 101 is 5. This would be your operand 2. When I made this slide, I didn't realize it, but I actually have a little typo in here. The reason why you have 8 bits for your operand is because that would say that this whole, that's the size of a data. That's the size of a byte of data that the processor can handle. So that's why it would be 8 bits. That's why we put all those zeros there. Also, we want to be able to handle a large number because if you're going to be doing adding operations with a computer, you want big numbers, right? That's the whole point of having a computer to do it instead of a human to do it, right? So
the opcode is always 4 digits, but the operand is always 8 digits.
Well, I won't say always. This is just an example. It depends on your processor, right? So nowadays, it used to be that we would have a 16-bit processor, right? And then it went to 32 bits, and now there are 64-bit CPUs, and it could be even larger than that in the future, right? So basically, the machine language is tied to the architecture of your computer. So it just depends. So for this, you don't have to, this is just an example. This is not something you're going to have to be tested on. Just understand that this is what a line of machine code would look like, and this is how we would break it down and code the different parts of it. Okay.
All right. Thank you.
Yeah, you're welcome. So basically, operand 1 in binary, I'm just going to leave out the 0, 7. That would be 7. That's 7, right? And then 101, that's 5. Okay. So if we looked at a language like down here, this would be a program all in machine code. It's tedious. It's not readable by humans, right? If I look on there, I don't know what that is. That's just a bunch of zeros and ones. It doesn't make any sense to me until I sit down and decode each line, right? It's not transferable to different microprocessors. Just like I was telling Charlie, it just depends. You have to have a machine code for the specific microprocessor or microcontroller that you are programming, okay? And it's low level, okay? So that's why machine language is not ideal. Humans don't want to deal with it if they can help it. So the next step up is assembly language, okay? So basically, assembly language is for your operator, you would have a word like add, right? And then you would have your two numbers. So that makes a little bit more sense, right? So you're like, okay, I'm going to add 4 and 5. That makes sense. So you would make your program. So here's a sample assembly language program. Then you would have this software called an assembler. You would assemble your program, and then your program turns into machine code that the computer can understand. Okay, so that's a step up from machine language, right? I would much prefer to deal with assembly than to have to deal with all those zeros and ones, but it's still not ideal either. And why is that? Okay, because it's not portable. It's tied to a specific microprocessor. So the assembly language that you would use for one processor, if you went to a different company, or if the company made a different family of processors, the assembly language would change and it would be specific to that microprocessor architecture. Okay, so that's not good. And it's still low level. It still can't do a lot of the stuff we would want to do at a high level. For every little operation, you have to have a line of code. And so the programs would get super long. Jessica, you took digital too. So weren't near the end, those programs were pretty long, weren't they?
Yes, they were.
They were very long, right?
Yeah.
Yeah, and then it's gonna be so much better when you're taking C to be able to do several things in just one statement. So you can't do that in assembly language. Okay, so that's one of the reasons why it's not ideal. So we came up with high level languages. Okay, so the reason why we like them is that they're more similar to natural language, like how we talk as humans. And they're not dependent on a microprocessor architecture. You can use them on any microprocessor or any microcontroller. And I don't think that I have defined what a microprocessor is, but I hope y'all know. Basically, it's like the Intel chip. It's just the CPU of any computer or any microcontroller, which is like a little mini computer that's made for a specific application to make your appliances smart. Okay, so what are some high-level languages? We've heard of a lot of them.
Would these be the ones that are like C, C#, C++?
Right. Python, you heard of Python? Java, Pascal. You probably haven't heard of that. I took that when I was in college, but I saw recently that some people still use it. I was shocked by that. Fortran, a lot of mechanical engineers use that. BASIC, that was the first language I ever learned in the 9th grade. So all of these are some high-level languages that people use now. They even have this new language called R, which is like more of a robot language that I'm interested in learning. The good thing about learning C is that after you finish this class, it's going to be so easy to pick up any other programming language, because C is pretty much the grandfather of all other languages for the most part. All of the newer languages, and maybe not Fortran and Pascal, but everything after that. Okay, so how do high-level languages work? Well, they still have to be converted into machine code. No matter what kind of language you come up with, it always has to be converted into machine code so that computers can understand it. So right here you have this, we call it source code, which is your C program. So say this is a program to add 2 numbers. We would name that add.c, okay? We have to send it through a compiler. it has to compile that C program into a machine code. Okay, the compiler that we're going to use is going to be called Code Blocks. You don't have to use this, by the way. This is just the one that I use. We were using CHIDE in this program, and you may have seen it if you use the lab computers, but they are no longer free. They want you to pay. So we're trying to use an open source free compiler because there are lots of compilers out there. There's no need to pay for it. All right. Now, there are some languages that are interpreted, and basically they do not generate an executable file. Okay, so basically you have, and one of them is like Python. Python is an interpreted language. Okay, so basically you have source code. It goes to the interpreter. And then the program is executed within the interpreter. So down here, I should say this is your .exe file. This would be add.exe. Once it goes to machine code, it becomes an executable. So down here, the program is executed within the interpreter. Okay. Now, as I said, Code Blocks isn't just a compiler. So there are some programs that all they do really is compile a high-level language into an executable language. But nowadays they have these programs called IDEs, which is an integrated development environment. Okay, so what it does is it lets you edit, because there used to be a time if you're not in an IDE, you have to use a separate editing program to type in your program and edit it, right? Then you have to send that to a compiler, and you may have to build it, and then you get out an exe file and you have to run that .exe file. You don't have to do that in an IDE. It lets you edit your program, compile the program, run the program, all in one environment. Okay, so that's really nice. You don't have to keep looking for files and typing in files to go into another type of software and all that. You can do everything in one software. So that's really nice and easy to use. All right, and so if we look at a graphic, what we see is that you could have a program right here that is high level code. You could go down one level to a lower level code, which is assembly, but it all, no matter what, has to be compiled into a binary code or machine language code in order for the computer to understand the set of instructions that we are trying to get it to perform. All right. So that's it for me. Any questions from you?
Can I ask a question about
Always.
it's a little unrelated to this, but it still pertains to the class. Since I know we're going to be writing code, I was wondering what by the end of the course, what is the most advanced code that we're going to be able to write, or that it'll be able to do?
You're gonna write some functions. I think you have to do something like create a calculator and a a couple of other things. So basically, you're going to learn all of the different commands or statements in the C language. Now, we're not going to do super complicated programs, but you're going to have the knowledge of the statements, and you would be able to do it if you wanted to. But because this is programming fundamentals, we're not going to get into super complicated long programs.
Okay, that's fine.
But you'll be, I mean, if you want to go off and do some on your own, you'll be able to do it. The only thing we're not going to get into is structures. And structures are important, but they're a little bit higher level. And because in this program, we're not programmers, we're not teaching you to be a programmer, we're just teaching you to understand basically where you would use programming the most in electrical and computer engineering technology is the computer engineering, because basically what computer engineering does is takes a little bit of a little bit of computer science, some electrical engineering, and kind of puts them together. And basically it's using the computer hardware and understanding the embedded systems that are in computer hardware or that are in smart applications, right? So whereas electrical engineering is more strictly hardware, computer engineering has programming and hardware.
Okay, thank you so much.
You're welcome. Anybody else?
Yeah.
Uh-huh.
You
Go
you
ahead.
go. You go.
Okay. Quick question. In your video, you suggested that we could get a C programming book. Would any do for this class?
Yes. Any
I'll-
would do. A lot of times I'll use the C for Dummies book. Some people don't like the dummies because the name is kind of insulting, but they're pretty good books, you know. But yeah, you could get any kind of C programming book and it would be fine to use, because basically this is what you're learning in this class. You are learning the syntax of different statements, right? And so all of the books are going to have that in them. So it doesn't matter what book you have. And also the online resources that I give you, the websites, they're good free resources as well. But I know some people prefer a book, which is fine. I prefer books too, but I'm trying to save you money. That's why we don't have a book.
Okay, thank you.
You're welcome.
Do you mind going over the homework that's due tonight at 9:30?
What do you mean going over it? What is it?
It's, hold on, I can pull it up.
Let me pull it.
It's the C programming, multiply C. Or no, wait.
Let's see, what's due tonight?
I think he's referring to the. Are you referring to the learning C programming?
On calendar it says CA learning C programming.
Oh, that's the class assignment. Okay, yeah. So the class assignment, learning C programming. So let me see what happened to my screen sharing. Oh, that's not it. Wait,
You hit side by side.
did I? I'm in the classroom. Can y'all who've had me before tell I'm trying to use this pilot? It's causing me some issues. Let's see, here we go. Okay. Can y'all see the Blackboard class now?
I can see.
The Blackboard course. Okay, so it's the class assignment, learning C programming. So let's go to lessons. Test one material. So introductory concepts. Well, where is it? Let's see. Let me go from here.
That was it, but the document that's attached to it leads to multiply C.
Learning C programming. Okay.
For me, the document attached was a short C program.
Lessons should be an introductory concepts. Oh, let's assume that.
It says a short C programming.
Oh, okay,
But-
simple C. Okay, y'all aren't seeing this simple C programs document.
Let me check again. I checked it or I don't know if it was yesterday or the day before, but I checked it and I printed out a document called a short C program.
Yeah, that's what it should. What is this? This is.
Yeah, if I click on it through the calendar, I'm getting a short C program.
Oh, learning C program. That's what it said, didn't it? Why was I in introductory concepts? Here we go. Learning C programming. Okay, here you go. A short C program. Okay. So what you're supposed to do is read through the components of a C program notes that are right here. All right. And then you're supposed to print out the short C program and label each component. And then type the program into code blocks and run it. Okay, so let's see what we have here. So if I open it, that's fine. Open it with default Word. Okay. Come on, thingy. Okay, so all right, so since we still have a whole nother hour, this is what I'm gonna do. We'll go over this. We'll go over this because we have time. So this is what you need to do first before we go over it. And if we do it now, all you'll have to do is just turn it in and I'll give you credit because you're here doing it. So let's see. All right, first I need you to read components of a C program and I'll be right back. So I'm gonna give you like 10 minutes to read that. And then what we're gonna do is we're gonna go through and as a class, so everyone be prepared to tell me, we're gonna go through line and we're gonna label what component of the program that line is, okay? So take 10 minutes
Sounds
or so.
good.
It might not take 10 whole minutes. Take 10 minutes or so and I'll be back. Probably might not need that many. Let me see how long. I don't think it's that long. I think it's 3 pages. Let's look and see. If you were in class, that stuff that you see on my screen, that's what you would be doing with a classmate. Yeah, it's 3 pages, so it shouldn't even take 10 minutes. So let's say 5 to 7. And if you need more time, I'll give you more time. Okay, so I'll be right back while y'all read that.
Who was it that said that the simple C assignment was due today? Because if I click through the calendar, I'm getting one assignment, and then if I click through the lessons, it's giving me an entirely different assignment. I don't know if that's like the same thing with you guys.
All right. Everybody ready, or you need a little bit more time?
Could I have 1 more minute?
Sure, sure. Oh, come on. I need side by side now. Let's see. All right, we need to get back to this being the shared screen.
Okay, I'm ready now.
Okay. Now I need a minute. Let's see, where is my print? Print. Okay. Okay, let's see if I can get it back to sharing the right screen now. Let's see. Let's share. Let's share. Okay. Where'd you go? Okay, can y'all see the notes? Can y'all see the short C program?
I can see it.
Okay. Okay, so this is source code. This is a C program, and the name of the program is multiply.c. Okay, so we're going to go through and we are going to label each line and say what part, what component of a C program it is. So let's start with Jessica, line 1. This is line 1. What is that?
It's a comment.
It's a comment, and comments are extremely important, y'all. Okay, so whenever you're writing your programs, I need to see lots of lots of comments, and you'll see them all over my program right here because I model it. First of all, the comments help you keep your train of thought, right? They help you understand what you are writing and what you're doing, because you may start to write a program and then you may leave and come back. So it helps you know what's going on. But the other thing it does is that it helps other people who use your programs understand what is going on, because in the workforce, you may have to read someone else's program and use it to fix something, or someone else may have to use your program and use it to fix something or install something. And they need to understand what you were thinking, what you were doing, what's going on, so that lots of hours of time isn't wasted. Okay, so I require that. If you look at my rubric, and I'll show the rubrics real quick before the end of the class is over. Something is missing. What happened to? Pretty sure that should be C. C is missing right there. So I look for comments, and comments are very, very important. Okay, so correct, that is a comment. Line number 2, James.
Line number 2 is print F, and it displays information on the screen.
No, no, no. Line number 2 on our program.
Oh, I'm sorry. I'm sorry.
Program. That's
Um,
okay.
I'm
That's
so
okay.
sorry. Sorry about that.
That's okay.
That's the include. It adds content from another file.
Exactly.
It has the extension period H.
.h, right. Exactly. So it's called an include directive. And basically it's just what James said. So there are lots of other programs and functions and stuff that you need to use that someone else has already created and that you can use and not have to totally recreate it in your user program. But in order to use this, these are all included in libraries, and you have to include the library in the file that you are writing, right? So stdio.h is standard input output.h. And if you didn't include that library in when you came down to the printf and the scanf, those functions wouldn't work. They wouldn't work at all because the compiler would be saying, I don't know what these are. They're not defined. Because remember, compilers are very literal. They literally read what you have written and they act upon that, right? So if you don't have in the right library that includes functions that you haven't defined yourself, then you're going to get an error that says function not defined. And normally when you get that, that means you either typed in the wrong function name or you haven't included the .h file or library file that needed to be included. Okay. All right. Number 3, Charlie.
The int a comma b comma c is your variables.
Right. So this is called a variable definition. You happen to know what a variable is, Charlie?
A letter or a symbol that defines a number.
Doesn't always have to be a number, but basically it is a place in memory, and we usually represent it by some sort of letter or name that is going to hold some data that has not been defined yet, right? So I like to describe it as like a cup, an empty cup, right? So you have the cup, you know the cup can hold something, but until you pour something in the cup, it's just sitting there waiting to hold some sort of nice beverage, right? So a variable is the same way. Everything in a program has to have a place in memory where it's stored, okay? So what the compiler needs to know, even if you don't define what A, B, and C are just yet, it needs to know, put some space aside in memory because I am going to put some values into these variables A, B, and C. Not just yet, but just put aside some space so that when I do define them, there is somewhere for them to go, okay? So you have to define every variable in your program. Now the int means that it's going to be an integer, a whole number, okay? There are different types of variables. There's integers, there are floating point numbers or doubles, there are characters, but this is telling the compiler this is going to be an integer. And the reason why the compiler needs to know that is because there's a different size of memory based on what type of variable it is. If it's an integer, depending on the compiler or the IDE you use, it'll be 2 bytes of memory. But if it's a character, it'll only be 1 byte of memory. If it's a floating point number, it'll be 4 bytes of memory. So that's why you have to specify what type of variable it is, okay? All right, number 4, Susanna. Line 4, Susanna.
Is that going to be your function prototype?
Yep. Or I like to call it a function declaration, just like you're declaring. I call this a variable definition. Sorry, that's a variable declaration. Or you can call it definition or either one. And this is your function declaration, okay? It's not the definition. The definition is going to be near the bottom, but it's just letting the compiler know, once again, there is a function that's going to be coming up sometime soon. Put some space in memory aside to contain this function. And what it's telling the compiler is that the answer that the function is going to produce is going to be an integer. That's what int means. That means that the result, the answer is going to be an integer. It's saying that the name of the function is product and that it takes two inputs. Okay, it takes an integer x and an integer y. Okay, so let's talk a little bit about functions. If you remember back in math, a function, it's kind of like a black box, right? On this side, you have inputs, right? And we just said for that product function, it had two, right? X and Y. Then it's going to have some output that's going to be an integer. We don't have to know a name yet, but we know it's going to be an integer. Okay, inside, because it's called product, I'm assuming that the actual function is going to be X times Y. Okay, so that's what a function is. It takes inputs, it does some sort of operation on the inputs, and then it gives you an output. This is your output. Okay, when we declare the function, just keep in mind that you have to know what the output is going to be. That's what the name is, because you're going to have to call it later on, and then what the inputs. You don't have to know like this X and Y. You don't have to, it doesn't matter what you call it. The compiler just needs to know that they're going to be two and what type they're going to be. Okay. All right, Thomas, line number 5.
Line number 5, I believe, is the main function.
It is. And it is the one function that every C program always must contain. Okay. It is the main function. But notice the main function is slightly different than this other function we have above it called product. Okay. For one thing, we don't have any inputs into the main function, right? And the reason why we don't is because it's the main function. It's the body that's containing everything. So if you looked at it as like a box, like we were talking about before, if this is main, this is your main program right here. This is main. Inside main, you have all these different statements, but you also have a function called product. Well, really, that's not true. Really, what you have, product is not in main. You call it a main, but it's really outside of main. So inside main, you may call functions. This is main.c. But nothing is being fed into main, right? But underneath it, you might have other functions, which are kind of like sub functions, right? Called product. It's very modular, right? So this is the main one that contains everything. And in here, you might call product, right? But product is outside, main is its own function, and you could have other functions as well. We don't in this program, but you could, okay? So just make sure you understand that. And when you call it, it's going to come out here, do whatever it's going to do, and then the answer is going to go back into main, okay? So that's your main. And sometimes you will see void up in front of main, and all that means is that it's not going to return anything. It's a function that does not return a value. So sometimes you'll see it, sometimes you won't. All right, line number 6. Who was that? Alexis. Alexis gone.
No, I'm here.
Oh, you here? Okay.
Mhm.
Line number.
It's a comment. It's another comment.
No, right here, right above the comment.
Oh, above the comment. It starts the function.
Right, it's a brace, right?
Mhm.
It just says that between these two braces are all your statements for the function, right? So it's the starting brace, it's the open brace that starts. It signals that the code below is in that function. It's in the main function or whatever function it is. Okay, so that's the opening brace, and then we'll just jump down to 15. That's the closing brace, right? Okay, so basically everything in between these braces is a part of the main function. That's what that says. Okay, that's what it tells the compiler. Okay, 7 is another comment. Let's go back up to Jessica. What about 8?
Is it a printf?
It is. And what is that?
So it'll essentially be what's displayed on the screen.
Right. So it's a function, right? So it's a printf, it's a function. And the inside these parentheses are the input into the function, which is a character string, right? And basically what it's saying is, I want you to print to the screen what I have in between these quotation marks, which is to enter a number between 1 and 100. So remember, this is a function, and it's a function that's defined in this library, but we just use it, and we don't have to sit there and define it ourselves. James, what about the line numbers 9?
Okay, so line number 9 is a function scanf, and it reads the data that's been input, I guess.
Yes, it reads the data from the keyboard and it assigns it into a variable. Okay, so basically what it's saying is, okay, so these parentheses, these tell you what the inputs are. This %d tells you the type of variable that it's going to be, and that means %d means integer. Okay, sometimes you'll see %i, but most of the time people use %d because it just means data. Okay, so that means like, okay, I'm going to put some data into variable a. All right, and this is the memory operator. This just says put whatever data that the keyboard is giving you into memory and call it a. Okay, so that is a function. This is the scanf function. And that was the printf function. All right, so then we have another printf, and notice the syntax. Syntax is what is going to cause you the biggest headaches in this class, okay? You will be sitting there forever looking for a semicolon that you forgot or a quotation mark or something. A lot of times compilers are smart and they kind of help you with stuff, but whenever you have a function other than the main function, at the end, you have a semicolon, okay? You always have a semicolon. That means it's the end. That's what a semicolon means. It's like the period in English, right? The period at the end of a sentence, right? That's what the semicolon is in the C language. It's the end. It signifies the end. All right, then we have another scanf. So we wanted to enter a number between 1 and 100. We put it in A. Then we asked the user to enter another number between 1 and 100, and we put it in B. This is what you have to understand too when you're writing a program. You're the programmer. And so whenever you have some kind of statement like a printf statement, you need to write it in a user-friendly way so that the user who may not know what was going on in your head, will not know what was going on in your head, understands what it is you want to happen. Okay, so if I just said something like enter number, they could enter any kind of number. They could enter 2000, right? So you have to be very specific and make it user friendly. So just keep that in mind, because I'll come run your program or the lab tutor will run your program and we want to know what's going on. We don't just want a cursor sitting there blinking, expecting us to input something and we don't even know what we're supposed to input. Okay. So 12 is another scanf. We're going to put the number that the user enters into variable B. All right. 14. Who did I start with, James? Charlie. What's 14?
Hold on, I'm looking. The C product is gonna calculate your variables.
Well, what it's called, it's gonna call a function that does it, right? So basically this is a function call, okay? It's kind of complicated because not only is it a function call, is that it's an assignment. So basically what it does is it calls this function called product, right? So that means it goes down here. I went too far. It goes down to this function called product. Okay, so the way that a compiler compiles a program is line by line. It executes one line, then the next line, then the next line. So when we get to line 14, it says, oh, I need to go down to this function called product. So it leaves main, okay, because remember, this is the end of main right here. It leaves main, it jumps out to this other function called product. inside product, there is a process going on, or a calculation, which is like a multiplication. It executes that, and then it goes back up to 14, and it assigns whatever that value is to C. Okay, so it's pretty complicated what it does, but basically it calls another function. That function does its thing, gives a result, and then the compiler sends that result back up and puts it into variable C. Everybody get that? Okay, because functions can be, that's one of the hard concepts for people, but I'm trying to introduce them sooner just so that you can understand it better. Okay, so that's a function call. Then there's another printf, right? Then there's the closing brace. So that means we're done with main. That's it for main. Then we have another function outside of main. So number 17, Susanna, what is line 17?
Is that another comment?
No, the one underneath it right here. Oh, can you not see?
Oh, okay.
Right here.
I'm trying to think.
So remember up here, we had a function declaration. So we've already declared it. So what do we have to do now?
To actually do the function?
Right. So this is the function definition. We have to actually define what it is, right? So the compiler knew that we had a function coming, but it didn't know, it didn't have a definition yet, right? So now we get down to the definition. Okay, so this is the function definition, and the definition has to match up here the declaration. So we said it was going to be an integer, so this has to be an integer, right? We said it was going to be called product, so it has to be called product. And we said it was going to have two inputs, which were X and Y, and it has to have that as well. Okay, notice there is no semicolon though, because this function has some more statements underneath it, right? So that's why there is no semicolon. So we open up the bracket that says everything in between these braces is part of this function. And basically all it does is say return. So in most functions, there's a return value. It's basically saying the return value is just going to be X times Y. Okay, so whatever X is, multiply that by Y, that is what is going to be returned up to C. Okay, and so that's the end of the program. So what you have to do is type this program into Code Blocks or whatever compiler that it is that you have. On this computer, I don't have Code Blocks. I have CHIDE. Most of the time, I'll have the program already written for you on Word so that all you have to do is copy and paste when we do these class assignments. But I don't for this, so you just do it, you know, on your own. But you'll type this into Code Blocks. You will fix any of the errors that you have in Code Blocks, and then you will you should get an output based on whatever input you put in. So if you put in, if the user put in 2 for A and 3 for B, you should get 6 as your output. Okay.
So, I didn't quite catch what line 19 was, the return X times Y. Is that the return function?
That's the return value of the function, of the product function. So basically, every time you have a function, if it does something, it returns a value. It's called, and then it returns some kind of value. Okay. So that's the return value. So the return value is going to be X times Y. Whatever the user puts in for X and Y, whatever that product is, it's going to return it back and assign it to variable C.
Okay, thank you.
Yeah, you're welcome. So basically it's like this. So we go back to our graphics. Okay, so we're going through main and we get down to the call C equals, right? So Charlie, give me a value for X.
7.
7. And Y.
14.
Oh man, I can't calculate that in my head. Now you're gonna have to calculate it. So what's 7 times 14?
Oh, 7 times. Oh, shoot.
That's gonna be 7 times 4 is 8 to 80, 88. Okay.
98.
Oh yeah, thank
Yeah,
you.
that's 98.
Thank you. 98. All right, that's why I like pencils. 98. So basically what's going to happen over here is that there's going to be a 7 here. There's going to be a 14. The answer is going to be 98. 98 is going to go back up, and then in C is going to be assigned the value 98 the first time you ran it. Say you run it again, and when you run it this time, A is 5 and B is 7. So then you come down here and you have 5 and 7. 5 times 7 is 35. So the second time you run it, C is going to be equal to 35, right? And notice, even though we call this A and B, it doesn't matter what we call that, because when we call this function called product, look what we put in. Look what we feed in as our input, A and B. It comes down here, and whatever those were, it multiplies those two, and then it returns whatever the product of those two numbers were back to C. Does that make sense?
Yeah, that makes sense.
Okay.
So we're basically telling the computer what to give the user as a prompt, and then the user puts in the variables and it calculates it.
Exactly. Yep. So as the programmer, we're saying enter a number, you're going to enter those two numbers, and then it's going to return the value. It's basically, product is basically like a calculator, like your TI-89, right? If you want to multiply two numbers, first of all, you have to call the multiplication function by putting in the multiplication operator, right? And then you have to put in the two numbers that you want to multiply. So that's all it is. It's just doing an operation. But instead of, and this is the thing, really creating a function to multiply something doesn't make sense, because that's just one line of code. The only reason why you have this program is because it just is an easy representation of what a function is. Okay. Normally a function would be something that's more complicated, that you don't want to have to write the code for every time you use it in your program. So normally a function would be more complicated than just multiplying two numbers. But right now, I don't want it to be complicated, because I just want you to understand the concept of what the function is in order to type in this program. Okay. So yeah, so you as the programmer is asking the user for two numbers, then you're calling this function that multiplies the two numbers and gives you back the result. And then you're printing to screen the first number times the second number equals the result. That's it. So your output should look like what I have right here. You should see first on your screen, enter a number between 1 and 100. Then second, you just say enter a number between 1 and 100, and then it should tell you what the output is, so that the user knows what's going on. So think about it in, like, if you were going to open up your Word file, right? You don't know what all the program that creates that software is. All you know is you want to be able to do what it is that you're trying to do, which is to create a document file, right? So that's when I say you're the programmer versus the user. If you open up a Word file, you're the user. You don't care what the programmer did. All you care is that you can make your document. But as the programmer, you have to make sure that your software is user-friendly, or your prompts to the screen are user-friendly, so that the user has a good experience. It's called user experience. That's what they call it nowadays. You want a very good user experience, and you want to think about the user, because back in the day, programmers would program stuff and they wouldn't think about the user, and your experience wouldn't be as great. It was really Apple that just took user experience to a whole nother level and made everything so intuitive, because they really thought about the person who was going to be using that software or using that product. So, any other questions?
I have like two questions, but I was trying to save them towards the end. I'm not sure if you have anything else that we're going to talk about or anything.
No, we're not going to talk about anything else. So you've already done the whole labeling. So the only thing you'll have to do now is you'll have to type in your program, and then you'll have to go over to the tutoring teams and run your program for one of the tutors so that they can check you off. Okay. So that's all you have to do for the rest of this class assignment. We've already done half of it. So you don't have to do that other part. You just have to type in the program, and then you have to, so hopefully you have a camera, a webcam. If you don't have a webcam, then what you're going to have to do is like talk to the tutor, and then you're going to have to send them your C program or post it on Teams, and then they'll have to put it into their IDE and run it and make sure it works. Okay. But if you have a webcam, well, no, that's not true. What am I thinking? You don't need a webcam for this, because all you have to do is pull up your IDE, run it. They'll see it running, and then they'll check you off. You submit the Dropbox. So let's go through that real quick. Any more questions about this before I leave and go to the class? Okay, so let's go to the Dropbox so I can show you exactly what that process is in case you haven't had me before. Several of you haven't. All right, let's see how I get there. All right, can y'all let's see. Can y'all see my Blackboard class?
Yeah, I can see the file with the notes, the program component notes.
Okay, so you can't see that. Okay, let's see. Still showing the hover cam, then I need it to show.
I could see the Blackboard.
You can?
Not anymore. Now that's.
Now you can.
Right. Oh, there we go.
Okay. Okay, so let's go. Let's move up. Okay, so first of all, let's just go back to the calendar real quick. Just so that you can know the different types of assignments. So if you see CA, that means class assignment. So normally those are going to be due if we have them. We don't have them all the time, but sometimes we have them. They'll be due after class normally. Okay, so that's a class assignment. If it says HW, that's homework. Okay, so that's a homework assignment. And then if it says P, or even over here, this is just an orientation. I don't call it a program because it's not a program. But if it says P, that is a program. And if it just doesn't have a little prefix, that just means it's an assignment, but it's not some specific type of assignment. All right, and then TL is the tutorial lab I talked about, where you'll go and the tutors will just test whether or not you understand the concepts or not. Okay. So if we go to lessons, we just finished the class assignment. So we go here, learning C programming. We go to class assignment.
So anytime that we have a class assignment where we have to put a program and get it running through the code blocks or something, we have to have that checked by the assistants, the tutors?
Yes.
Okay.
Yeah. Unless we have time. Like if we had time, we don't have time today. If we had time, because normally when we have this class, I want y'all to go ahead and bring up code blocks or whatever IDE you're using. And so if we have time, like today we had time to go over it, we'll go over it. And then if you can share your screen with me and I can check you off, before class ends. But if class ends before you've had a chance to get checked off, yes, you have to go to the tutors and they'll check you off just like if it was a program.
Okay.
Okay.
Mm-hmm.
So to submit this, basically what you'll do is you'll click the Dropbox. Okay. In the comment section of the Dropbox, you will list the name of the lab tutor who checked you off. Okay. Whoever checked you off, you put it there because they'll be putting your name in an Excel file saying they checked you off. You'll put your name here. That's how we double check, because sometimes you will forget to put the lab tutor's name, which you need to remember, because I don't know that you did something unless you put their name. Sometimes they'll forget to put you in their file, but if you have it here, then I should be able to find it. The other thing is we should be able to see it in Teams because it makes a digital timestamp of everything, but just make sure you put it here. If you had to attach something, which you don't for this assignment, you would use the attach files here, and make sure after you think you've attached something, you should see the name of it. Let's just do it so you can see. Okay, you see right here? I see the name of it, okay? Make sure you see the name of what you attached. And to be sure that it's like works the way it's supposed to, why is it not coming up? You normally can click on it, you can open it just to make sure it's not empty, but I don't know, mine isn't working. But anyway, just make sure that at least you see that what you attached really was attached. And then you click submit. Don't forget to click submit. Sometimes you won't see submit and you'll see like okay down here, and you'll have to click okay, and then it'll take you to submit. All right, any questions about submissions? The other thing that you have to do by Saturday, I believe, is your orientation lab. So you would go here, you go test 1. Okay, so you go down to lab assignment. Okay, so for this one, you only have a checkoff. Normally there's a checkoff and a documentation, but for this one, there's only a checkoff, right? The checkoff for this orientation, what you're gonna have to do is go over with the lab tutor how to use code blocks. Has everyone downloaded it?
I downloaded it, but I don't see a submission box for documentations on other labs.
You don't?
No, I was looking around and I asked one of the lab
Oh.
assistants, and I don't see that anywhere.
Yeah, I don't know. I'm getting my classes mixed up. There's no documentation for this class.
Okay.
Basically, there's just a checkoff, but you just attach your .c file and your flowchart. So there
Okay.
you don't write up documentation because it's a program. So it's not, you're not building anything. So yeah.
Okay,
There,
yeah.
there is no, y'all, I'm teaching like 4 different classes this summer and it's been crazy and I've been having a lot of issues this week. So pray for me. But yeah, there is no documentation. There is only the checkoff, okay? But on the checkoff, you attach, your .c file and your flowchart. And we'll talk more about flowcharts, I think, next week. But for your orientation, you're going to have to learn how to use draw.io. Some of you may already know it if you already took any of the other ECET, like the digital class or the digital, what else did we use it for? Mainly digital too, flowcharts. But if you don't know it, you're going to learn it. And remember, it's a web software. So you don't download it or anything. And when you save your file, you have to export it as a .png file or a JPEG. If you attach your draw.io file, I cannot access it. Okay, so make sure you remember that. You have to export it as a .png or a .jpeg file. Okay, so what you're going to do is you are going to you're going to recreate the flowchart I gave you, which is a flowchart about 7 steps for writing good code. Okay, and then you are going to type in another program and get it to work. Jessica, you don't have to do this flowchart. All you have to do is put a note that says, I already took digital too. Okay.
Oh, I actually already did that lab.
You already did? Okay, because I know.
Yeah, I did that lab and I recreated it and everything, but I did redraw the how to make a sandwich flowchart. I did kind of I made a new one just to kind of refresh myself on the flowcharts and stuff.
Okay, all right, that's fine. In this program, you have to type into code blocks and make sure you can compile it and get it to run. So that's the orientation. Basically, it's just it's going to help you learn how to use code blocks and debug and do a flow chart, which is very important. Any questions about that?
I have one question about code blocks.
Mm-hmm.
So when you hit create a new project, it brings up like another tab and it asks you to choose different.
Don't create a project. Just go into new file, create a file.
New,
yeah. And just
and then
and do it in there instead of creating all those different projects. Those projects are a headache. I can't go into it right now because this computer does not have code blocks. It has CHIDE. So I'm trying to think off the top of my head, but you can create a new file without creating a new project and just have all your files be in that same project, which I would kind of label something like programming or something like that.
So do I create a new file or create an empty file?
You do an empty file.
Empty file.
Empty file. Okay.
Mm-hmm.
Oh, yeah, that's easy.
Got it? Yeah.
Yeah.
Okay. Yeah,
Thank you.
that's the one thing that's annoying about code blocks, the whole project stuff. But if you don't create a new project, you shouldn't have a headache. And make sure you have the Ming version. Hopefully you have that, because the other versions tend to give headaches as well. I don't know why, but they do. All right. Any other questions?
I just have one. I know I already emailed you about it, but on the calendar file that you put up on Blackboard, I printed it out and it says that there's an assignment called Introduction Presentation, but on the calendar that doesn't show up. I don't know if that's just an assignment that you decided to take down or anything.
I thought that was next week.
It says it's due the 8th of June, but I don't see that on the calendar on Blackboard.
Oh, is that okay? I don't know why it's not showing up on the calendar. Let's look. Let's look at my course schedule. Yeah, we don't. Yeah, I do normally have that. Oh, there it is. Introduction presentation. Yeah, it just must not be showing up. So, y'all, sometimes Blackboard just doesn't show stuff up, which is annoying. But if it's on the course schedule, if I haven't, why are you not showing up? Let's go. Listen. Oh, it's hidden.
There we go. I just refreshed it. I see it.
No, you see it? Yeah, it looks like for whatever reason, it was unavailable. It has the right date and everything, but it just wasn't showing up. Yeah. So basically what you have to do, and if you already took me for any other classes, you can use the exact same presentation, but you just have to create a quick little presentation and you're going to present it here on Teams to the class, just so we can kind of get to know each other. So basically you're going to share your screen and you're just going to tell us a little bit about yourself. It doesn't have to be long. Include pictures. I love pictures, but we'll do that.
You said you refreshed it and it's showing up for you? It's still not showing up for me.
Huh, that's surprising because, I see it on the calendar now. Introduction presentation. Huh. I don't know why it's not showing up for you. Go to lessons. You're in lessons?
I didn't see it. I didn't see it on the calendar, but
so you just saw
I
it
see it in lessons.
Okay, let me try to see if it's in lessons.
I don't know why it's showing up on my calendar. I don't know why it's not showing up.
Yeah, you're right. It's not on
Okay, yeah, it's showing up for me now too.
In lessons or on the
In
calendar?
lessons, yeah, it's not showing up on the calendar.
Okay. Yeah, so y'all really need to go back and forth between the Word file, or I think it's an Excel file now, and the calendar. Sometimes stuff just does not show up on the Blackboard calendar, and I don't know why, because it's showing up on my calendar, even though it's not showing up on y'all's calendar. Because if you look right now, I'm sharing my calendar. You see, it's showing up on my calendar, but it's not showing up on y'all's. I don't understand why. But yeah, that's what. But why? All right, so this is what you do. I have it due on the 8th. You're going to put it on Microsoft Teams. So yeah, let me show you how to do that real quick. And then you're going to give it on Thursday during the class, okay? But it's going to be due on the 8th. So what you would do is you would go to Teams. You would go to Teams, okay? And then I guess you can put it on this channel. That's fine. Up in files, you would go. Can y'all see?
We just see the colorful background.
Oh gosh. Okay. This is so annoying. I don't know what's wrong with that. It has something to do with the way these classes are set up. From now on, I'm gonna do it at home anyway, so it doesn't matter. I just had to come here today.
Would we just be able to screen share the presentation or?
Yeah, that's what you'll do.
Okay.
Can you see Teams now?
Yes.
Okay. What is going on? Why does it keep going back and forth? Okay, you will go over to Teams, okay, and then you will go up to Files, and then you will just say Upload, and then whatever file, whatever your presentation is, once you create it, we'll just put Automation and Technology are here. Open that up. And bam, it's there. Okay, so then it'll already be here. And then when you come to class, all you have to do is we just go to files and click on it. And then you just share your screen and we can go through it that way. Okay.
Okay.
Anybody got questions?
With the presentation, do you want it on PowerPoint or just any sort of presentation?
Yeah, it should be on PowerPoint. I don't know if Prezi will work. Prezi might work. I mean, the thing about Prezi though is just that it should work because all you have to do is share your screen. You can't upload it though.
Oh,
You can just upload a link. So you could put the link. Yeah, what you could do is just upload the link and then you could use it. But yeah, it shouldn't be Word because that's not a presentation software. Okay, that's a documentation software. So either PowerPoint, Prezi, and I don't know of any other documentation software. What's the Apple presentation software? No one has it, so okay, it doesn't matter. But yeah, so yeah, that's what it needs to be on. Anything else before we stop? All right, Charlie, I guess you're gonna have to push stop recording because I don't even see it. Let's see if I can get back to where we were. We were.
Let's see if I can
Get
find
back
it.
to our meeting.
hold on. One more question.
One more question? Okay.
Sorry,
Oh,
you might be able to hear me a little better now. I noticed on the calendar, it says, which dates are due, but in the lessons, it doesn't give a date on any of the lessons on when those are due.
No, you have to look at the calendar or you have to look at the course schedule. Lessons doesn't let you give a date. I mean, it might. I thought it did. You sure it doesn't? Wait, let's see. Once you click on it, it doesn't get, you have to click on the submit. You have to click on the Dropbox, I think, in order to see the date.
Oh, okay. I see it now. I
You see
wanted
it
to
now?
ask because I know you said we had to go back and forth between lessons and calendar. I see it now. Thank you.
Mostly the calendar works, but not lessons. I was saying go back and forth between the course schedule, which is like an
Oh.
Excel file. go between that. So I would just print that out. You know what I mean?
Yeah.
Or, just look and just, go over it like Jessica did. If you go over it at the beginning of the semester, it should be sufficient, right? But sometimes the tests don't show up, and I normally just put like a hard, test 1, test 2, or whatever in a calendar without it being able to click on anything. But every now and again, just like this one, sometimes stuff just doesn't show up, and I don't know why. So yeah, you just look at the course schedule, and it has all the assignments on it.
Okay. All right. Thank you.
Yeah, because for lessons, you got to click on the box or whatever. Whereas with the course schedule, you just click on the Excel file and you're done. Any other questions? All right, so we will see you next week. Oh yeah, and then what I was going to say is for some people, you might not find it necessary to come to class. I see that a bunch of people didn't on the first day, which is surprising. But my policy is that if you have an A in the class, actually, I think I said something like an 85 as your grade in the class, then you'll be exempt from the class, the online class. You don't have to come unless you just want to. Okay.
Okay.
Because I'm mainly here for people who just need the help and just to break down, stuff. And a lot of times, like I said, mainly you learn C programming by programming. So a lot of times my lectures won't be as long as they were today. Normally they're about 10 minutes at most. And then what we do is we're going through, the lecture might take longer than 10 minutes, but the talking part is about 10 minutes, but we're going through putting in programs, seeing how they work, because that's how you learn how to program, not by me talking to you. It's a skill, right? So you have to program. So keep that in mind as well. If you have any questions, please just reach out to me. Email is good. Please take advantage of the tutors. Like right now, let's see who's on duty. I think it's Charlotte. We got an ECT tutoring, online tutoring. It's Cliff. So right now, if you wanted to join Cliff, if you had some problems, if you want to go ahead and get checked off for your class assignment, you would click join, and then you would run your program for him, and then he would check you off, and you would put his name in the comments as the tutor that checked you off. Okay?
Okay.
If you have a quick question, you can just type in the chat, and they'll answer the question as well. If you don't feel like joining the video, you don't have to if it's a quick question. So it's up to you, but we have tutoring all day long, 9 to 10 every day, even including Saturday and Sunday. So please take advantage of it. All right.
Okay.
Any last questions? We got 3 minutes left. None?
I don't have a question, but I finally found where to stop recording.
Oh, where is it?
It's right next to the screen share button, the 3 dots.
Oh, uh-huh. Oh, it says stop recording. Oh, okay.
Yeah.
Cool.
And that's where I started the recording.
And then I'll have to see where the recording goes. I'm assuming it's going to go right underneath like session or something like that, but I'll find out. Okay. Yeah, let's hope. I hope I don't have to go find it. Okay, well, I'll talk to y'all next week. Have a good weekend. All right.
All right.
Thank you.
You too. Bye-bye.
Welcome.
Bye.
Bye.